Now let's talk about the most important part of functions, the function arguments. So, what are the clean code practices for function arguments that exist? And what are these best practices that have been suggested by Robert Martin in his book Clean Code? Well, we often used to think that the brackets of functions are the free spaces to utilize, and we can fill that space with as many arguments as we want. The more information we pass to a function, the better it will perform. But Robert Martin argues that that's not the case. The ideal number of arguments for a function is zero, which he called as niladic. Next comes 1, monadic, followed by 2, dyadic, and 3 arguments should be avoided. Triadic should be avoided. Now you can say that what's the case with more than 3 arguments, like polyadic? Well, you must have a special justification for that, and that should not be used anyway. So, the point which he is making here is that the arguments are hard. They take a lot of conceptual power, and even from the testing point of view, they are harder. Imagine the difficulty of writing all the test cases to ensure all the various combination of arguments work properly. So, in the point common monadic forms, what he is emphasizing is on the justification to passing the arguments to a function. There are two common reasons to pass a single argument into a function. Sometimes we try to find an answer to a question through that argument, and sometimes we try to operate on that argument. For example, here in these two functions. In the first form, we are only passing an argument to check whether the file exists or not. So we are only trying to find an answer to a question. And in the second case, we are passing this argument to operate on that argument by transforming it into something else. We are passing a string, my file, and we want to return an input stream object. So these are the two common forms of functions with single arguments. One must choose names that make the distinction clear and always use the two forms in a consistent context. If you are trying to find an answer, then your function name should sound like that. Like in this case, it is clear that the function is checking whether the file exists or not. And if you're trying to get something out of that function, then your function name should reflect that too. So the idea is that the form of your function should reflect in the name. And apart from that, for the functions that process on some event, the names should be chosen more carefully. It should get clear from the name of the function that you have called it on some event. Remember the event handling functions provided by the Java Standard Library. Action performed, component resized, component moved, key typed, key pressed, key released, mouse pressed, mouse clicked, mouse entered, mouse released, and so on. Only by listening the names of these functions, one can get an idea on what types of events these are going to get called. So when you are writing a customized function for some event, then the name should be even chosen more carefully. The next point is about the flag arguments. Flag arguments means the Boolean arguments, arguments that return either true or false. Such arguments complicate the signature of the method because if a function is taking Boolean arguments, it means it is performing more than one thing for sure. One thing for true case and another for false case. So such kind of arguments should be avoided. The next point is about the dyadic functions, the function with two arguments. A function with two arguments is harder to understand than a monadic function. But there are times, of course, where two arguments make sense. In case of two arguments, there should be some form of natural ordering that exists. One must keep that in mind. That dyadic functions are useful, but they come at a cost. So, if there is any mechanism available to you to convert them into monads, into single argument, then follow that. Same is the case with the triads. Triad functions that take three arguments are significantly harder to understand than the dyads. The issue of ordering, pausing, and ignoring are more than doubled. So, Robert Martin says that one must think very carefully before creating a triadic function. You should have a good reason to do that. And when a function seems to need more than two or three arguments, it is better to wrap those arguments into a class of their own. Consider, for example, this: reducing the number of arguments by creating objects out of them may seem like a cheating, but it's not. When groups of variables are passed together, the way x and y are in the example, they are likely part of a concept that deserve a name of its own. And this is where we put them inside a class object. And sometimes we want to pass a variable number of arguments into a function. In that case, we can declare a variable object. For example, here in this scenario, this string format function's second argument needs can hold more than one argument. So in that case, we can declare the second argument as the variable argument. And the function that take variable arguments can be monad, can be dyads, and can be triads. So these are some of the common norms that we must follow to keep our functions clean, simple, readable, and precise in their intent. The next point which Robert Martin is making here in this part is about the verbs and keywords pair. In the previous video on functions, we have already discussed how choosing good names for a function is essential. And in the case of function with arguments, verbs and keywords should be chosen in a way that they explain the intent of the function and the order and intent of the arguments too. For example, in the case of a monad, a function with a single argument, one can choose a verb or noun pair like this. If the function name is right, then put the argument name as name. Now, only by reading the name of the function, one will get an idea that this function is here to write some name, or a more precise one can be write field and then the name. So, this verb and noun pair works well with the single argument function. And in the last case, in the second case, this assert expected equals actual. This is an example of the keyword form of a function name. Using this form, we can encode the names of the arguments into the function name itself. For example, assert equals function can be better written as assert expected equals actual. This mitigates the problem of having to remember the ordering of the argument because the ordering of the argument is clear from the name of the function itself. That expected is going to come first and then the actual argument. In the next point, we have to remember that we must write the functions in a way that have no side effects. Well, you can ask what can be the side effects of the functions. Side effects are the lies. If your function promises to do one thing, but it also does other hidden things, then that's a lie. And if it has more effects than it intended to, then we can say that these are the side effects. Sometimes it will make unexpected changes to the variables of its own class. Sometimes it will make them to the parameters passed into the function or to the system globals. So Robert Martin says that in either case, they are devious and damaging mistruths that often result in strange temporal couplings and order dependencies. For example, here in this particular code example, this function uses a standard algorithm to match a username to a password. It returns true if they match and false if anything goes wrong. But this function has a side effect as well. The side effect is the call to session initialize. The check password function, by its name, says that it checks the password. The name does not imply that it initializes the session. So, a caller who believes what the name of the function says runs the risk of erasing the existing session data when he or she decides to check the validity of the user. This side effect creates a temporal coupling. That is, the check password can only be called at certain times. If it is called out of order, session data may be lost. So these kind of temporal couplings are confusing, especially when they have a hidden side effect. If you must have a temporal coupling, you should make it clear in the name of the function. In this case, we might rename this function with something like check password and initialize session, though they're definitely going to violate the single responsibility or do one thing principle. But then that will justify the name of the function. The next point is about output arguments. Well, you must be wondering that arguments supposed to pass input to functions. So what is an output argument? Sometimes the arguments that we pass to function, assuming it to an input, is actually an output. How? For example, in this case, when we say append footer and we pass an argument, does this function append s as the footer to something, or does it append some footer to s? Is s an input or an output? To check that, we need to see its signature. And the signature is public void append footer string buffer report. So that means the S is the object of the report. Now we are clear that argument is the output. So anything that forces you to check the function signature is equivalent to a double take. It's a cognitive break and should be avoided. These days, we do not used to have the output arguments in our object-oriented languages, but if your function is designed in that fashion, then there must be better ways to call such a method. Like would be better for the append footer to be called as with the report object itself, the report dot append footer. In general, output arguments should be avoided. If your function must change the state of something, have it change the state of its owning object. That's the point which Robert Martin is trying to make here. Next point is about command query separation. That means function should either do something or answer something, but not both. Either you do a command, either you run a command or you run a query. Don't try to mix the two. Either your function should change the state of an object or it should return some information about that object. Doing both often leads to confusion. For example, here in this case, this function sets the value of a named attribute and returns true if it is successful and false if no such attribute exists. This leads to confusion if we consider it from the reader's point of view. It is hard to infer the meaning from the call because it's not clear whether the word set is a verb or an adjective. Next point, which is related to this, is prefer exceptions to returning error codes. Returning error codes from command functions is a subtle violation of command query separation. It promotes commands being used as expressions in the predicates of if statements. And also, when you return an error code, you create the problem that the caller must deal with the error immediately. On the other hand, if you use exceptions instead of returned error codes, then the processing code can be separated from the happy path code, the normal path code, and can be simplified using the catch handler. But when we try to put try catch block inside our functions, they make the code look messy and confuse the structure of the code too. So, a good practice is to extract the try catch block into a separate function. One must extract the try catch block into a function and instead call that function when appropriate. Remember that error handling is one thing. Function should do one thing. Error handling is one thing. Does a function that handle errors should do nothing else. This implies that if the keyword try exists in a function, it should be the very first word in the function and there should be nothing after the catch finally blocks. Another problem dealing with the error code is that it usually implies that there is some class or enum in which the error codes are defined, and that creates a dependency. The other classes must import and use them only for the sake of getting the error codes. And for any kind of change in error code, all the dependent classes will need to be rebuilt and redeployed again. So we definitely would not want to go into that situation. It's always better to use exceptions object instead of error codes. And a final thing that we must keep in mind all the time is dry. Do not repeat yourself. Duplication of code is the root of all problems in the software. All our core principles and practices in all sorts of programming paradigms are focused on only one thing: controlling or eliminating the duplication. A developer must keep this in mind. Now, after listening so many talks around only the function names and the function arguments, one can wonder and can ask how we can practice to write functions like that with the approach that we have just discussed. So, on this, one thing we need to remember is that writing a good piece of code is very much like writing an article or an essay. When you write your thoughts down, they are generally very rough and very unstructured. But with each and every read, with each and every pass, you make them more and more polished, well structured, well connected, and well formed. And that's the case with the code as well. It's not that when you will start writing your code, you will keep all these points in mind. It is only after writing your basic logic, your core function, then you must spare some time, take some time out, and think about the overall structure of your functions, their role in the larger system, and their overall conceptual meaning and relationships. And in that phase or in those phases, you polish your functions again and again. And finally, you reach to a point where you can say that your functions are now clean, readable, understandable, and have all sorts of good quality features that we expect to see in our code. So that's it for the functions and their arguments. In the next part, we will try to explore what are the clean code practices for the comments, the lines that we write next to our functions, not for the compiler, but for the reader of our program. So we'll discuss that in the next part.